Thank you all for sticking around. I realize I'm at the end here. You might be tired. I will try to be enthusiastic. And also to position this, I don't work with neural nets myself. So when I was asked to do this, I thought, talking about my own work in grammar engineering is not going to be a strong contribution to this workshop, to the dialogue here. So instead, this is more commentary on what I see as a linguist at ACL, basically what I see going on there. So that's, I'm not really going to be talking about my own work very much. There's hardly any numbers in this. The claims that I'm going to make, and hopefully these are not controversial, but I wanted to put them out there. First, human language is a general purpose communication tool. Right? When we as humans learn languages, we learn something that is not task specific. Work on NLP, neural or otherwise, isn't general purpose yet. Instead, I see two types of work. I see stuff that is task-focused and task-specific, and I see stuff that is linguistic structure-focused and therefore maybe not task-specific, but not itself solving any real-world communication task. If we're going to get to general-purpose NLU, that's natural language understanding, that's going to require learning or building a system that can map between strings and linguistic meanings. And this is probably the most controversial claim here, but I'm very strongly committed to it, i.e. something like a grammar. And hopefully this will become more concrete as I go through some of the examples here. Basically what I'm talking about is the difference between sentence meaning and speaker meaning. So sentence meaning is the standing meaning, the thing that is the linguistic convention, what it is that we know about the meaning of the sentence independent of the particular context of use, right? And that sentence meaning does not determine the situated speaker meaning, but it's an important cue to it. So as competent speakers, when we hear someone say something, we are not just directly unpacking their message from that string of words. We are using that string of words as a very important clue to their communicative intent, but it is not directly packaged into it. And I learned this way of thinking about it from Reddy 1979, which is a very weird and very wonderful paper, and I strongly recommend it. It's not written to me as an audience, but it's fantastic. I really enjoy it and recommend it. For NLP, outside of artificial annotated data sets, or maybe naturally occurring annotations, like when you scrape Yelp and you get those stars, machines don't actually have access to direct representations of speaker meaning. Right? What machines get is natural language utterances, and then we would have to reason from there to the speaker meaning. In the artificially annotated data sets, we have a specific representation of the speaker meaning we're trying to get to, but once we are outside of that training data, we don't have that anymore. Right? If we want to get to general purpose NLU, my claim is that we need a task-independent, comprehensive representation of sentence meaning that captures exactly the information that's in the linguistic signal itself, so that we can then reason from that to the task-specific speaker meaning. So my goals, this is a case where this isn't really the right audience for this talk. Like these goals here are not for you, it's for the NLP crowd, and mostly not the NLP crowd that showed up here. Right? But still maybe it's interesting, I hope, as a contribution to this dialogue to hear about these goals. And so basically I want to make NLP researchers aware of the sentence meaning, speaker meaning distinction, and the importance of sentence meaning, and it seems pretty clear to me that that awareness is not generally there. And I see lots of nodding. And also I want to find effective ways to bring linguistic knowledge both into NLP systems and into NLP research. And so that's sort of a lot of what I do when I'm talking to that other audience that informs this talk that I'm doing right now. So to prepare for this, I thought, well, let me take a snapshot of what's going on. So I went and I looked at the ACL anthology for the ACL long papers from 2017, and I just pulled the ones that have the word neural in the title. Now that is a subset of the ones that were using neural methods, right? Sometimes it would be attention or something else in the title that would tell you this is neural. But I just picked the 50 that actually use the word neural in the title. And then I did a survey of those papers. I looked for what's the task, what is the input and output to the neural net, what representation, if any, of natural language syntax is being used, and what's the notion of meaning in that paper. Right? And this was definitely a superficial survey. Right? I didn't read many of the papers end-to-end. I read some of them end-to-end. I was not concerned with the details of the model. I was looking for these things, which frankly was not the part that most of the authors were most interested in. Right? They were more interested in the details of their model, and I was looking at this other stuff. So what tasks did I find in these 50 papers? I've categorized them here into a few buckets. Some of them were concerned only with form, or form plus a notion of meaning, which is like, you know, a word by the company and it keeps. right? But not anything beyond that, not relating the words to any external notion of meaning. And here I just want to take issue with something that Jason said at the beginning of his talk, that if you can do production, you can also do comprehension. I think that's only true if your production starts from some non-linguistic representation of communicative intent. And if what you're doing is language modeling for production, then that's not going to get you comprehension for free. Because the language modeling is not relating the form to any actual meaning. So that's like
sorry, what I meant was a latent variable production model that had the interesting variables in it.
Okay,
sorry,
yeah. So unpacking what you said a little bit. All right, so the people who are looking only at form or form plus company keeps meaning, we're doing things like language modeling, poetry generation, which is kind of cool. All right, and there the input is like, well, here is a form you have to stick with and some keywords to give you the theme. Right, and then did this turn into a poem was the evaluation. Similarly, effective language generation, there the input was the prefix of a sentence and then an emotion that it should express. And then you got a sentence that was happy or a sentence that was sad. I put topic modeling, categorization, and grammar correction into this category. There was lots of papers as usual on machine translation. I separated that out from anything to do with meaning because machine translation really these days is looked at as sequence to sequence, and it's not really about capturing meaning, it's about capturing, yeah, I've seen the pizza on the pizza oven on the table or whatever lots and lots of times, and so I'm just going to spit that out again. There were papers analyzing linguistic structure in a non-task specific way. For someone to back up and say this neural leads to English MT was really cool though. This was looking at a neural net trained game system and then having humans play the same system speaking in English and trying to find ways to map the messages between them. That was a neat idea. So analyzing linguistic structure in a non-task specific way, so parsing to different semantic representations like abstract meaning representation or English resource semantics, various kinds of syntactic parsing, text coherence identification, paradigm completion, and word segmentation. So these are all analyses of linguistic structure not focused on a particular task. And then there were the papers that were identifying a specific kind of speaker meaning in a task-specific way. So argument mining and frame detection was one type there, a bunch of papers on relation extraction or question answering against databases or question generation together with these databases. Sentiment analysis was another category here, including sentiment abstract extraction. So not only did people like this restaurant, but what did they like about it? What were the categories? Was it ambiance? Was it food? Was it service? That kind of thing. I put emotion detection and sarcasm detection there. There was a couple of papers on going between English and computer languages. This one that was doing Python code from English was particularly frustrating to read because they made a huge deal out of modeling the syntax of the programming language and failed to mention or take any account of the fact that the natural language has a syntax too. Dialogue modeling, and then abstractive summarization, image captioning, and I didn't know actually where to put geolocation of tweets. It wasn't even really meaning, but I had to put it somewhere, so I put it in this last category. So this is just a survey of the kinds of things that people were looking at who were inspired to use the word neural in their title for their ACL 2017 paper. I looked also at the representation of natural language syntax, which mostly there wasn't at all. All right. The folks working on parsing tended to have syntax because that was their target. There was entity grid, which was basically noun phrase chunks plus is it subject, object, or some other grammatical function, so a tiny little bit of syntax there. There was literal chunks. And then there was word embeddings used to capture syntactic categories. So not a whole lot of natural language syntax going on right now at ACL. Another reason this is the wrong audience for this talk is that all of the things I would have liked to have seen in these papers at ACL were in the talks this afternoon and this morning. So thank you for that. All right, what about notions of meaning? So again, people parsing to specific task agnostic representations had the associated notions of meanings. So abstract meaning representation is more or less a representation of sentence meaning. I argue in the IWCS paper I'll point to later that it's a little bit veering off into speaker meaning because of the way the annotations are done. English resource semantics is sentence meaning based on the English resource grammar. Predicate argument structure, syntactic isn't quite meaning, but it's kind of towards that. And then the paradigm completion paper, which I think is Ryan's work, was looking at morphosemantic features and relating that to surface form. So that's another kind of meaning. Sometimes the notion of meaning was embeddings. either of characters or words. There was one paper that did sentence embeddings as a weighted sum of word embeddings, which seemed like a really rough approximation of compositionality to me. And you could also have topics as clusters of words. Sometimes the meaning was in affective content or emotion. The knowledge-based population stuff was all looking at relation triples. And the neural leads to English was looking at the belief induced in the interlocutor, which is grounded in gameplay. So this was a very pragmatic notion of meaning. And there was another paper that looked at user intent within ontology-constrained slot filling. If I were in less of a rush, I should have put all of the references here instead of giving you the breadcrumb if it's got the name neural in the title. But this one was looking at sequential question answering against the knowledge base. And so again, the knowledge base was defining a set of slots that could be filled. And so it was this very constrained, task-specific notion of user intent. And then there's some stuff that was grounded in images. And so the notion of meaning was image. Okay, so sentence meaning and speaker meaning again. When we do this, when we learn correlations between domain-typical surface forms and task-specific representations like SQL queries or images even, or Yelp reviews or the slots, all these kinds of things, what we're doing is we're conflating the timeless conventional standing sentence meaning, that is the property of the linguistic signal, what it encodes, with the utter occasion speaker meaning, an aspect of the communicative intent in that situation. And when we make that conflation, then we have a couple of problems as NLP engineers. So on the one hand, we're going to be resolving the same problems around grammatical structure each time. Right? English works basically the same way every time we use it, no matter what we're using it for, in terms of its morphology, syntax, semantics, and even pragmatics. And if we're going to keep doing this on a task-by-task basis, we might get a learning system that could be learned across multiple different tasks. But if you train it on one task, it's not going to be able to perform a different task. And that's not what we see humans doing. Coming back to my claim that for humans, language is a general purpose communication tool. And the way we are learning linguistic systems right now in NLP, we're not getting there. So my claim, and this is the longer version of this is in a paper I wrote with co-authors at IWCS in 2015, is that sentence meaning, unlike speaker meaning, is compositional, and that systems that attempt to understand speaker meaning would benefit from reusable, automatically derivable, task-independent representations of sentence meaning. And furthermore, if we do that sentence meaning compositionally, and this is in opposition to the way AMR is done, we're going to get more comprehensive representations. They're going to be more consistent and more scalable. And that 2015 paper is looking at basically a grammar-based version of creating sembanks that gets you really nice properties this way. And I will come back to those sembanks later. In order to make that argument, I had to come up with a working definition of compositionality, which is here. So a meaning representation system is compositional for my purposes if it's grounded in a finite but possibly quite large number of atomic symbol meaning pairings. Those are going to be the morphemes of the language, including multi-word expressions. Where it is possible to create larger symbol meaning pairings by combining the atomic pairings through some finite set of rules. And the meaning of any non-atomic symbol meaning pairing is a function of its parts and the way they are combined. But the way they are combined can have idiosyncratic contributions to the meaning. So I don't take the very strict, it's only function application like you get sometimes from a CCG perspective. That's this level. Fourth point, the function is possibly complex. And any further processing will not need to destructively change a meaning representation created in this way to create another of the same type. Basically, if you have to do sort of fix-up things, then you've lost compositionality, in my sense. So in this 2015 paper, came up with that definition, and then it did a survey of the various things that we annotate for in preparing data sets for computational linguistics, and classified them as sort of below composition, and then composition, and then the stuff that's above the compositional layer. And so for today, I've just got the compositional layer. The claims are these are the things that are compositional. So predicate argument structure is the most sort of key example of compositional meaning. But you also get, out of a grammar, for example, partial constraints on things like the scope of negation and other operators, the restrictions of quantifiers, modality, tense aspect and mood, information structure, so topic versus focus versus background, the discourse status of reference of MPs. This is sometimes called definiteness, but it's a bit more general than that. Politeness is sometimes partially grammatically constrained. And then there was this other category here, something that looks compositional but not according to sentence grammar, which is coherence, relations, or rhetorical structure. Okay, the sentence grammars that we build don't constrain that because they go one sentence at a time. But there seems to be some sort of a discourse grammar that you could also do. So I like to make the point when I'm talking to NLP crowds about the importance of syntax in recovering sentence meaning. And I have this example from a language that some of you recognize and some of you don't. And I say, imagine you're building a sentiment analysis system and your system gets ABC data. And my point here is to try to make it look not immediately obvious what it means. So if you read this language, imagine that you don't. And the reason for that is that in our own experience with language, we're not aware of our own linguistic processing. So when we look at strings, the meaning is just there. And so it's easy for people who are not trained in linguistics to assume that the meaning is just there, that the words wear them on their sleeves. And so it takes looking at another language to see that it doesn't. So here's my sentence, you're building a sentiment analysis system, what do you do with this? And I say, here, I'll tell you the language is Japanese, did that help? Right? I'll tokenize it. Did that help? All right, now I'm going to gloss the content words for you. Okay, now we know something about what the sentence is about, at least, if not what it means. And then the next step is I'm also going to gloss the function words. And what happens at this point when I do this is I usually can get someone in the audience to tell me what they think the sentence means. Jason did this for me once. But this is a cleverly selected sentence to show the importance of syntax. Japanese is a head final language. So perhaps unlike what you expected, this sentence means, according to the teacher, girls like Pokemon more than boys do, because of the direction of attachment of those, what are actually postpositions in Japanese. Right? The point of all that exercise is to say, in order to get to the meaning of the sentence, you need the scaffolding of the syntax. So, back to my claims. Human language is a general purpose communication tool. What we're doing right now in NLP, neural or otherwise, is not yet giving us general purpose communication tools. Instead, we get task focus and task specific work, or linguistic structure focus that's not directly doing any tasks. And in order to do general purpose NLU, we need to either learn or build a system that can map between strings and linguistic meanings, i.e. something like a grammar. So, these are my goals again. How am I going to do this? Well, some of the stuff that I've done is writing textbooks. So I have this book on morphology and syntax, Linguistic Fundamentals for Natural Language Processing, working on a second volume in the same series with Alex Laskarides on semantics and pragmatics, trying to make sort of the basics of how language works accessible to an audience that hasn't spent a lot of time in linguistics classes. We can also bring linguistics into NLP through reviewing practices. So brief advertisement, Coling 2018, I'm a PC co-chair, it's going to be in Santa Fe in August. And we have created review forms that highlight the relevance of linguistics to NLP. So we're asking the reviewers to look for that in the papers. And so I hope to see a lot of linguistically informed submissions and to see them rise to the top. We can also do error analysis best practices. And I keep waiting for somebody to write this paper, and I'm afraid I might have to write it. But how do you actually do an error analysis that is linguistically informed so that we can find things like, well, what are the phenomena that trip up my system? And that was also what we were trying to do with Allison and Sudha and Hal, and then I was sort of occasionally meeting with them and giving a little bit of input, organized the Build It, Break It shared task last year at EMNLP. And the idea there was to have the builder teams create systems as usual for a sentiment analysis task and a semantic role labeling task, and then have breaker teams try to come up with examples that would not only stymie the system, but be closely related to what the system could do to help find that boundary. And I hope that that kind of shared task will persist in the future and be a way to bring these kinds of linguistic insights into NLP. And then another way, so those first four are really about bringing linguistics into NLP research, not necessarily into the systems. I also want to point out the value of taking large-scale encodings of rich linguistic knowledge as an input directly to NLP systems. And the one that I particularly want to highlight, I mentioned before, is the English Resource Grammar, which is a broad coverage precision grammar of English. It's been under development since 1993. Yes, there are people still doing rule-based computational linguistics, and it just takes persistence, all right? And we've gotten there. So Dan Flickinger is the main author of that. If you take well-edited English text and you throw it at the ERG, you now get a reasonable parse out, including semantic representation, for over 90% of the sentences. And we have some robustness measures so you can get something back even if the ERG is not giving you a native representation. And also there's genre-diverse, large-scale tree banks built with this. And when we did an inter-annotator study in that 2015 paper, we had ridiculously high, it was like in the 70s, exact match agreement across annotators, right? The entire semantic structure exactly the same. Because the way that it's done is the grammar provides a range of possibilities in the parse forest, and then the annotator is selecting among those using minimal discriminants, which is very efficient and gets you very clean, consistent annotation across very rich representations. So I just want to put in a plug for this. If you're working on English, this is a fantastic resource, and you can use it as a parser. You can use the tree banks. I don't particularly care how you use it, but I'd like to see it used more than it is. So, I think this is my last slide. I want to end with the question of, does true machine NLU require a hand-built grammar? Do we need something like the ERG, and do we need it for every language we're going to work on? Not necessarily. All right, I'm not going to die on that hill. That would be silly. But my bet is that some kind of grammar, either built or learned, will be required. We need something that does that mapping. And the way we're currently setting up NLU-related machine learning tasks isn't generally, and sort of present company accepted, isn't generally leading to grammar learning. So, how are we going to get there? Well, NLP needs linguists to better understand the shape of the problem and to better evaluate progress. And that's it.
Time for a few questions for Emily.
Yes, Chris.
Chris Dyer, so I am really happy that you brought up this contrast between sentence meaning and speaker meaning in the context of a workshop on neural networks, which is, we are in the neural network paradigm, we are always optimizing some loss function. And if the sort of claim you also made that language is a general purpose communicative system, there's a really interesting tension there, I think, between those two things, because it's not obvious that you would need a sentence meaning if you only, or that a system would develop a sentence meaning if all it was seeking to do was maximize communicative efficiency. Now it might, but I personally, and this is why I've tried to put various kinds of biases to encourage the things that we think should be in language to emerge from the data. But I think these systems need to be helped along. But I guess my question is maybe a bit more broadly. I mean, what this tension? Do you think? Why do you think sentence meaning exists independent from speaker meaning? Why do we have that in language?
Why do we have sentence meaning in language? And this touches also on ideas that Chomsky has that I very much disagree with. So, right, so Chomsky would say, no, language is not first and foremost a communication tool.
Right,
and I think that we have it independent of speaker meaning precisely because that's what allows us to generalize across contexts. So when we take our linguistic knowledge that we've learned in one situation and we go use it somewhere else, that sentence meaning helps us build a bridge. And I think that if we build tasks along those lines, and I saw Jacob's presentation was sort of edging in that direction, where if you do some learning with one set of input-output pairs, but you did it in a way where you then knew that you had to take the resulting system and go do something else with it, that would, I think, encourage finding these abstractions, and you would probably find that your work with putting those biases in, or Noah's work that he was talking about at ACL, which didn't show up in my survey because your paper wasn't in the thing. But you don't like the idea of multitask learning with the sentence meanings as a way to sort of bring it in and help generalize?
You didn't use the word neural.
Oh, you didn't use the word neural, yeah, right, sorry, I didn't survey for squash. Inside joke, I'm sorry. Yes?
So I guess to respond to both of those things, I think it's actually pretty clear for a lot of natural language processing tasks, especially in low resource settings, that we have some kind of transparent, or not necessarily transparent, but some representation of meaning from which we could extract things like tense and aspect and definiteness and all that, that it would be really useful for doing things with less data. At the same time, it seems like we can actually get a lot of the way there using the kinds of representations that get generated by just things that have been translated to do or trained to do machine translation or natural language inference or whatever, where what you get out at the end is some kind of vector, but it's a vector that you can query using some kind of model for all of these structured linguistic properties that we think are really important. So I guess the question for Emily is like, if we can do that, if we can have some kind of vector that some learned model can answer all these questions that we know linguists care about, is that enough?
Maybe train with multitask, right?
Yeah, exactly.
But it's just not it doesn't look anything like it.
So, I mean, yeah, I don't particularly care what it looks like. I mean, I would be excited as a linguist to see it looking like something like I would build, but I'm not, I'm not committed at all to HPSG feature structures being in the wetware, right? That's not where I'm coming from. And so the question is not, does it look like a linguist grammar, but can you use that representation, perhaps trained multitask, on a held out task and have it work?
All right, let's thank Emily again.